Hello everyone, my name is Brian Deladogbe. Today we're here to design a logic diagram for a 4 by one multiplexer and a 2 by 4 decoder. So let's begin. So first of all we get our AND gates, get 4 of our AND gates, like this, and get our OR gates. This. Make sure you place it at the right place. So we therefore change this get 4 inputs, for this as well. For this as well. Yeah, like this. For here, get to use 4 inputs, change it to 4 inputs. We then connect all our OR gates and our AND gates. Connect them. Let's remove this from here. Bring it a bit closer. Connect to the last one. Okay, so make sure everything is intact for the connections and everything. Now pick these gates one after the other. use three inputs for each. Three inputs for each. So we then take two NOT gates and bring them down here. Place them here, right here. After that, we need to take six of our input logic gates, six of them. Take six of our input logic gates. The first one, second one, third one, fourth one. So we then connect them, like this. Yes. These ones I'm just changing the sizes. So like this, yes. So now we have four inputs and it's left with a multiplexer to get a data line. So with these two NOT gates, so once it's done, you need to get an output. To get an output, yes, like this. Get an output like this, yes. Then connect it like this, yes. So we get the other two inputs. Yes, like this. The other two inputs, making the input 6. So we have to attach these two inputs to the NOT gates, just like this. Yeah. So we now connect the lowest OR gates to the NOT gates. Connect them to the inverted ends over here. Yes. So both pins must be connected to the inverted ends of the NOT gates, like this. So we then move to the top gates, the top OR gates, and connect them to the inverted ends of the NOT gates, connect it, and do same for this, like this. So we then move to the second OR gate. Second OR gate must be connected to the inverted end of the NOT gate. One must be connected to the inverted end of the NOT gate, and the other to the non-inverted end, like this. So one connected to the inverted end of the NOT gate, and the other connected to the non-inverted end of the NOT gate. So we then do the same for the third OR gate. One connected to the inverted end of the NOT gate, and the other connected to the non-inverted end of the NOT gate, of the other NOT gate. So you see from here, this is connected to the second inverted end of the NOT gate, and this side is connected to the first inverted end. Sorry, the first non-inverted end of the NOT gate. So for now, simulation is enabled, and you can check when there is a 00. So now you can check for the data. Yes, it works. There goes the output. No output, no output, no output, still no output, no output. When we get to this, we get the output over here. So thank you guys, that's all for today for a 4x1 multiplexer. So our next one, it will be the 2x4 decoder. 2x4 decoder. So we're about to begin the 2x4 decoder. So we get our decoder. Yes, right there. It's it somewhere here. So this is the decoder. So we can see there are two inputs and then two outputs. But we need to do something first. So we have to disable this so we can see one, one of our inputs gone, and get our outputs to be 4. So in order to get the outputs to be 4, change this bit to 2 bits. There you go. Get our 4 outputs. Now we need to connect our outputs. Let's connect our outputs. So we need 4 of them. 4 outputs. Sorry. to get our output. Yeah, get four of them. First, second, third, and the fourth. There you go. So you then connect them. So you connect them very well. Like this. Yes. So this is how we do it. The output connects first one to this, to the output over here, second one to this, third one to this, and the fourth one to this. Yes, this is how we do it. So now we then connect our logic state to our logic state. Place it somewhere here because outputs here, inputs over here is one. So we use one and connect like this. So we change this database to two. Yes, to a ratio form, something like that. So like this. So now we try selecting them. So when it's when it's 00, we get this to be enabled. Change here to 01. Second one is enabled. Change it to 10. The third one is enabled. Change it to 11. The fourth one is enabled. So this is how the decoder works. This is how it works. 00 for this, 01 for the second one, 10 for the third one, and 11 for the fourth one. Basically, this is how the decoder works. Thank you very much for your time. Goodbye.